Guys, today we are going to focus on series and sequence. So follow me to the end of this video and you understand everything you have to know about series and sequence. If you are new to this channel, just hit the red button below to subscribe. So now let's start. A sequence is a set of numbers or terms written in a definite order with a rule or a formula for obtaining the terms. So let's give an example for you to understand. Let's say 1, 3, 5, 7, 9, 11 and also 2, 4, 6, 8, 10. You can see that 3 minus 1 is equal to 5 minus 3 in the first set of numbers, which is equal to 7 minus 5, which in all we had our answer to be 2. So you can say that the first set of numbers differ by 2. Let's move on to the next one. And also 4 minus 2 is equal to 6 minus 4, which is equal to 8 minus 6, in which we had our answer to be 2. So this one you can say that the second set of digits differ by 2. So what can you think about this? You can say that to get a next successive member, you have to add by 2. So in this case, we call this a sequence because it has a specific pattern that it follows. So let's look at series. A series is formed when the terms of a sequence are added. So it's formed when the terms of a sequence are added. For example, let's take the first sequence that we have: 1 plus 3 plus 5 plus 7 plus 9 to infinity. Note that if the series stops after a finite number of terms, it is called a finite series. So this one you can't say it's a finite series because you don't know the end number. So this one is an infinite series. So the vice versa, which is the finite one, that it has a finite number that you get the final series for the sequence. So let's continue with the types of sequence. So the first type of sequence that we have is the arithmetic progression, sometimes called the linear sequence. And the second one that we have is the geometric progression or the geometric sequence, also called the exponential sequence. So an arithmetic progression is a sequence in which any term differ from the preceding terms by a constant called the common difference. So let's take an example to illustrate the arithmetic progression. So let's take 2, 5, 8, 7. So you can say that 5 minus 2, arithmetic progression, they differ by a certain number, which is constant true. So 5 minus 2 should be equal to 8 minus 5, which is equal to 3. So this we can say is an arithmetic progression because it has a common difference, a constant difference, in which if we subtract from any preceding terms, we get 3, which makes it an arithmetic progression. Let's pound on learning the arithmetic progression. Let's consider this. The first term of an arithmetic progression is denoted by A, and the common difference is denoted by D. So now, the first term, which is U1, which is equal to A, you already know that the first term is A. And the second term, you can get it by adding the common difference. So U2 is equal to A plus D. And who can guess for the third one? It is obviously A plus 2 times the D, because you have to add 2 of the difference to the A in order for us to get a third term. So from this you can say that UN will be equal to A plus N minus 1D, because for U equals 3, U3 is equal to A plus 2D. You can see that the 2 will be 3 minus 1, which is, so where n is the number of terms and Also, L is the last term. So take note of this formula used in the solving of linear sequence. Take note of, you'll be using it where L is the last term, A is the first term, and D is the common difference, and N is the number of terms. Also take note, the common difference is equal to the second term, that's U2 minus U1, not U1 minus U2. This is a wrong way of solving it. You can't do it in this way, or else you get your answer wrong. So I'm pasting the formula here for you not to forget. I'm pasting it here. So let's take an illustrative examples. So the first one that we have, the 11th term of a linear sequence of a form 4, 9, 14, 19 to infinity. So solution. By giving the sequence to be 4, 9, 14, 19 to infinity. From the question, you can see that the number of terms is, because they say we should find 11 terms, so the number of terms will actually be 11. You understand? And our sequence 4, 9, 14 and 19. So this one you can say that our first term is 4, and this one we're not giving our last term, so you can't use the last term to find anything in this question. So our first term, which is equal to 4, and our common difference, which is denoted by D, is equal to 9 minus 4, also equal to 14 minus 9, which you had our answer to be 5. So our common difference here is 5. So now, what is the question saying? The question says that find the 11th term. So the 11th term, it maps that n is equal to 11. So U11 will be equal to, by the original formula that we have, will be equal to the first term, which is A, which in this question you have A to be 4, and n minus 1, which is 11 minus 1, times the common difference, which is 5. So 4 plus 10 times 5, because 11 minus 1 is 10. Moving on, you had our answer to be 54. So our 11th term is 54. So let's take the second illustrative example. This says the 8th term of a linear sequence in a form 47, 42, and 37 to infinity. So solution, the 8th term, it implies that the number of terms n is equal to 8, and the first term from the question is 47. So the common difference is equal to 42 minus 47, which you had an answer to be negative 5. So from the formula, we can say that U8 is equal to 47 plus 8 minus 1 times minus 5. You can say that 47 plus 7 times minus 5, which you had an answer to be 12. So the 8th term is 12. So let's continue with the third question. So find the number of terms in the following sequence. We are told to find the number of terms in the following sequence. This time around, we're giving the last terms. In order for us to know the number of terms, we're giving the last term. So remember that UN is the same as L. It can be represented as L, which is the last term. Let's continue. Solution. So the first question, it says that 3, 7, 11 to 31. So it maps that the first term, which is A, is equal to 3, and the last term L, which is equal to 31. So we can say that our common difference is equal to 7 minus 3, which is equal to 4. So using the formula, this formula, L is equal to A plus N minus 1 D, which I've already told you that UN can be the same as L, the last term. So L is equal to A plus N minus D. You can say that the last term, which is 31, which is equal to 3 plus N minus 1 times 4. So our aim is to find N, which will give you the number of terms of this sequence. So now you can say that 31 is equal to 3. You multiply through by 4, the n minus 1, you multiply, so 4 times n and 4 times 1, so we are getting 4n minus 4. So you send the 4 and the 3 to the other side of the equation, making 4n be equal to 31 minus 3 plus 4. Note, because 4 here was negative, so if we move to the other side of the equation, it becomes positive. So 4n is equal to 32. Dividing through by 4, 4 cancels 4. Here 4 cancels 4. 4 cancels itself 1 and going to 32 8 times. So simple and short, you can say that n is equal to 8. So the number of terms is equal to 8. Very simple. You can try, and at the end of this video I'll be giving you questions to try, and if you have any problem or difficulty with this, just comment in my email section or like send me an email for me to answer that one for you. Let's move on to the second one, which is 2, negative 9, negative 20, minus 141. So our last term is here is minus 141, and our first term is 2. So now we can say that our common difference is minus 9 minus 2. It's actually giving us minus 11. So here we will not write any formula because you are used to the formula. So it's actually the last term, which is minus 141, which is equal to 2 plus n minus 1. Outside the bracket we have minus 11, multiplying through by minus 11. So now the n minus 1, you multiply through 8 by the minus 11. So that's what you are about to do now. So minus 141 is equal to 2 minus n plus 11. So moving the 11 and the 2 to the other side of the equation, we have minus 11n is equal to minus 141 minus 2 minus 11. So minus 11n is equal to minus 154. So dividing through by minus 11, dividing here 2 by minus 11. The minus 11 cancel out. Minus 11 goes to 1 and goes to 154 14 times. So obviously our number of terms is 14. Very easy to do. So therefore our number of terms are 14. So our next question, which is find a formula for the n term of the linear sequence 10, 6, 2, minus 2 to minus 2. But the minus 2 is not our last term, it was known to infinity. So the solution, the n term of a linear sequence is given by, you know already from the formula, un is equal to a plus n minus 1 bracket close d. Never forget this formula. So where a, which is the first term, is 10, from the question that we were given is 10, and the common difference, which is 6 minus 10, which we had the answer to be minus 4. So n means the number of terms. So un is equal to 10 plus n minus 1 bracket close minus 4. So our aim is to find the formula in which if you put the number of terms inside, you can get the un. So 10 minus 4n plus 4. So we had the answer to be 14 minus 4n. So now you are going to look at forming the linear sequence when two terms are given. You can actually form the linear sequence when two terms are given. So when the two terms of the linear sequence are given, it is possible to find, yes, it's possible to form the sequence by first finding the first term and the common difference. So these are the only two key things you have to find in order to get the rest of the sequence: the first term and the common difference. So illustrative example. The first question we say that find the linear sequence whose 8th term is 38 and the 22nd term is 108. For the 8th term, n is equal to 8. So u8 is equal to a plus 8 minus 1, or into bracket d. So I can say that a plus, because we said the 8th term is equal to 38, so you can say that a plus 7d is equal to 38. Don't be confused with that, because in the question they give us the 8 term to be equal to 38. So let's name that equation 1. Also, for the 22nd term, n is equal to 22. So it maps that u 22 is equal to a plus 22 minus 1 bracket close d. So now we are using the 22 now. So a plus, so 22 minus 1, which is giving us 21. So a plus 21d is equal to 108, because in the question they were given that term is equal to 108. So let's name that equation 2. So equation 1 minus equation 2. With this, we are using the elimination method to find our values for a and d. So note how I do it, so that you too can learn and use it on your own. A minus a, we are getting 0, so we don't write it. So 7d minus 21, we are getting minus 14d, and 38 minus 108, we are getting minus 70. So now we can say that our common difference d is equal to minus 70 over minus 14, which we had our answer, because we know that minus will cancel, and 14 divided by 70 we had 5. So put the value of d into equation 1. We are getting a plus 7 bracket 5 is equal to 38. So note how I solve the elimination method, and you can apply it on your own and it will work. So a is equal to 38 minus 35, because 7 times 5 is 35. So the answer is 3. So the value of a is 3. So a is equal to 3. So now you are getting our common difference in our first term. Now it has become easy for us to find our sequence. So we know that the first term, which is 3, which is becoming our first term. The second term is actually the first term plus the common difference, and the third term is actually the first term plus 2 times the common difference, because you have to add 2 common difference, which we are getting 3, 8, 13 to infinity. You can't write all the numbers here, so you have to initiate it by dot number. Now these are the questions that I want you to try your hands on. The first one, which is